Okay, section 5.4 is we're going to do a proof, but this is going to be a little bit different type of a proof than what we've done in the past, and it's called an indirect proof. Before, we prove things directly with direct logic. Um, there was actually chapter 2 where we talked a little bit about logic in there, and we remember we skipped it. So, but that's okay. We don't really need to know chapter 2 to be able to do what we're going to do today. Let me just tell you a little story. Here's a story about indirect proof. Okay, so you're sitting at home, and the shades are closed. You don't know what's going on outside, and you don't know what the weather's like or anything. And maybe it was calling for rain, and you're not really sure it's raining. Well, somebody comes home. My wife comes home, or your mom, or dad, or brother, or sister come home, and they have an umbrella in their hand. And this is the indirect reasoning or indirect proofs. You kind of do this all the time without even thinking about it. So it's like this. So you're sitting on the couch watching TV, and you see your brother or sister come in, and you're wondering if it was raining or not. So what do? You look at them, and they're holding an umbrella, but then they have that umbrella, and it's completely dry, and it's not wet at all. In fact, it might not even be open. So you're going to see that. Oh, here's a picture of an umbrella right there. Okay, so make you remember this a little bit. So you see the umbrella, and the umbrella is completely dry. So you make a conclusion. Okay, what is your conclusion then about whether it's raining or not outside? You look at the umbrella, you look at the clothes that they have on, you look at their hair, okay, and nothing's wet. All right, the umbrella's not wet, the hair is not wet, the clothes, the shoes, nothing is wet on them. So what do you conclude? You conclude then that it's not raining outside. So that's kind of an indirect way of looking at things. You didn't directly look outside and open the blinds and say, oh, nope, it's sunny outside, it's not raining, or I don't see any rain on the ground. You didn't do that. You figured out indirectly that it was not raining. And we do that all the time with many, many other situations. But that's just one situation that I could come up with. So what we're going to do is we're going to actually do that type of reasoning. So anyway, that's kind of like an introduction to this, and we'll see how that kind of fits in here in a second. What I'm going to do now is show you some steps. These steps are right in the book, but I typed it up on this program right here, and we're going to look at the steps on how to do an indirect proof. If you look in the book, you're going to find this on page 351. So if you look on page 351, you can see all this, but I've just listed it right here. So let's take a look at the very first step. Just like any proof that we've talked about, I don't really expect, oh my, I spelled the word wrong. I don't really expect you to get a complete understanding of this just by watching this one video, okay, or just doing this one lesson. It does take a little bit of time, right? So I don't really expect you to be able to get this 100%, but I want you to get a good idea on what we're trying to do and how to do it. It's really not that bad, okay? I kind of like these indirect proofs, tell you the truth. So let's see what it says to do, and then we'll take a look and we'll do some examples. You really, I don't think, will have a great understanding of this until you look at the examples. So how to write an indirect proof. The very first step says, identify the conclusion you were asked to prove. So what were we trying to prove with this umbrella thing? We were trying to prove that it is not raining outside, right? So that's what I want to try to prove. And the first step says, make the assumption that this conclusion is false by assuming that the opposite is true. So what were we trying to prove? We were trying to prove that it is not raining outside. So let's see. Let's scooch this up a little bit right there. And we are trying to prove that it is not raining. And we don't need to say outside. We assume that it's going to rain outside if it does. So we are trying to prove that it is not. This is when you use indirect proofs. This is the big time when you use indirect proofs. When you're trying to prove something is not. Okay, so we're trying to prove that it is not raining outside. So what does this thing say to do? It says make the assumption that this conclusion is false. This conclusion right here, we want to say this is false. How do we do that? We assume that the opposite is true. So first thing we're going to do is we are going to assume that the opposite of what we're trying to prove is true. So what's the opposite of it is not raining outside? Well, we assume that it is raining outside. You're probably thinking, what in the world? All right, but just bear with us, okay, and we'll go through this. So that's our very first thing. This is very important. This is one of the most important things on indirect proof. You always assume that the conclusion is false. You always assume the opposite right here, that the opposite is true. If we're trying to prove that it is not raining, then we assume that it is raining. Okay, let's look at step 2. So we did step 1. Step 1 was we just assume the opposite of what we're trying to prove. Step 2 says use logical reasoning. Now this is the part that you have to think a little bit. Use logical reasoning to show that this assumption leads to a contradiction. Okay, that's the key to this contradiction. And we're going to talk about that quite a bit. So use logical reasoning to show that this assumption right here, leads to a contradiction of the hypothesis or some other fact. All right, such as a definition, postulate, theorem, or corollary. Now, we don't really have definition, postulate, theorem, or corollary when we talk about this raining situation. We will use that when we talk about the geometry stuff. But for right now, we want to use logical reasoning, use facts, okay, use our thinking ability to come up to a contradiction. So what was our situation? We're sitting in the house, we see the person coming in the house, and there is no rain. There is the umbrella is dry, the clothes are dry, the shoes are dry, everything is dry. So what does this assumption lead to? It leads to a contradiction. Because what's the contradiction? The contradiction is if it was raining outside, right? We're assuming it's raining. So if we assume that it's raining outside, what must be true about this umbrella? Okay, if the umbrella is used properly and not tucked inside the jacket or something, if the umbrella is used properly, right? That's logical reasoning. We come to a contradiction. The contradiction is that the umbrella is dry. That's the fact, okay? If the umbrella is dry and they had it outside and they brought it in and it was open and it's dry, guess what? That's a contradiction to the assumption that it's raining. So if we thought it was raining and the umbrella is dry, what did we probably figure out? We probably figured out that that assumption is false. And we're going to look at that right here in a sec. This brings us to the third point. It says, point out that since the assumption leads to a contradiction, that's what it did. See, this assumption that it's raining, it led to a contradiction because the contradiction was we saw no water on this umbrella. Okay, it was not wet. It was dry as anything. That's our contradiction. So that assumption led us to a contradiction. So the leads to a contradiction. The original conclusion, which you're trying to prove, must be true. So if I assume the opposite right there, okay, if I assume the opposite and it contradicts a given fact, what's the given fact? The given fact is that the umbrella should be wet if it's raining outside. So there's our contradiction. So guess what? The original, what you were asked to prove must be true. So if I contradict this, the assumption, then it must be true. Our original conclusion, okay? I'm sorry, I don't like how he said that, the original conclusion, but what you were asked to prove, okay, that's what I want to see. What you were asked to prove must be true. I hope that makes a little bit of sense. I was looking at an old video when I taught this last year, and I used an example of me like playing for the Phillies. So I said, indirectly prove that I do not play for the Phillies. So what do? You assume the opposite. So you assume that I do play for the Phillies. And now you use some logical reasoning to show that that's not true. So what if I did play for the Phillies? Well, if I played for the Phillies, then I probably wouldn't be teaching in school. I'd be, well, actually, I guess I could because, well, let's say it this way. If I played for the Phillies, I'd probably be, you know, a millionaire, okay? Most of them are making more than $1 million. Or I would be getting a paycheck from the Phillies, which I don't. What's another thing? Well, I would be a very good baseball player, which I'm not really that good of a baseball player. I'm an okay baseball player, but not a very good baseball player. So that's a contradiction. What else is true? I would have a Phillies uniform, and I don't even own a Phillies uniform. Got t-shirts, but I don't have a Phillies uniform. That would be a contradiction. I could go on and on and on. So what did I do? I contradicted the fact that I said I played for the Phillies. So what must be true? It must be true that I do not play for the Phillies. So I could go on and on with different examples like that. And that's kind of what indirect proofs really are. Well, let's take a look to see how this relates to geometry. Okay, here's some geometry. This is a right triangle. What I want to do, I want to prove through an indirect proof, I want to prove that a right triangle, cannot, and again, that's when we usually use indirect proofs, when we want to prove that something cannot or is not equal or something like that, okay? So prove that a right triangle cannot have an obtuse angle, all right? So this is just kind of basic thing, just to kind of get you an idea of what the indirect proof is all about. So we want to prove the right triangle cannot have an obtuse angle. So what do? What's our first step? Our first step, if you remember what we wrote down, we want to assume the opposite. We want to assume the opposite of what we're trying to prove. We're trying to prove that a right triangle cannot have an obtuse angle. So we assume that this right triangle, does have an obtuse angle. All right, so that's what I would write down. I would assume the opposite of this. So let's just mark it here. We'll call this triangle ABC. And it doesn't matter which angle, let's use this angle right here. So let's say this angle right here is an obtuse angle. In fact, to make this a little easier for us, let's actually put a number in here. Let's just use 100 degrees. That's obtuse, isn't it? It's more than 90 degrees, all right? You can pick any obtuse angle that you wanted to. So we assume that this right triangle does have an obtuse angle. And there it is right there, 100 degrees. Remember, we're assuming the opposite of what we're trying to prove. So we assume that it does have an obtuse angle. We'll call that angle A is obtuse, okay, or 100 degrees. So now what we have to do is reason logically to come up to a contradiction. The contradiction should be fairly easy to see here, because watch what happens. If I take that right angle, that 90 degrees, and I take this 100-degree angle, and if I add them together, what do I get? I get, oops, I don't get 180. I get 190 degrees. Just with those two angles, I get 190 degrees. But what happens? This contradicts, doesn't it? This, I'm going to write it down. This contradicts the facts, okay? What is the fact? This contradicts the fact that a triangle, I should say this, that the sum of the angles of a triangle, sorry for my messy writing, angles of a triangle must equal 180 degrees. See what I did? That contradicts. This right here says the sum of these two angles equals 190 degrees. But that contradicts the fact of something that I already know, that the sum of the angles of a triangle have to equal 180 degrees. There's no way. This can't be like negative 10 degrees, can it? All right? That's the only way that I could get this to be 180 degrees. And you know you can't have an angle with a negative degrees. So that's our contradiction. So we say this. So what we assumed, let's do it like this. So what we assumed about the right triangle having an obtuse angle, is false. Is false. I always like to put false in all caps. Okay? We'll even put a exclamation point for emphasis. All right? So what we assumed about the right triangle having an obtuse angle right there, see, that's what we assumed, isn't it? We assumed that it had an obtuse angle. That's false. All right? And I just showed why it's false up here. Therefore, we're just going to state what our conclusion is. Therefore, a right triangle, and all I'm going to do is restate what I'm trying to prove here, up here in white. Therefore, a right triangle cannot have an obtuse angle. And that's basically how we write the proof. Notice, there's no two columns, there's no statements, reasons. It's basically, it's this. What's our first step? Our first step is to assume the opposite. That's our first step. Assume that it does, or that it does. See, we're trying to prove that it does not have, I put cannot, you can put does not have an obtuse angle. So I assume the opposite, that it does have an obtuse angle. Then we reason logically. So this right here is our logical reasoning right here. So I said, okay, let's make one of them obtuse. Let's add them up. I get 190 degrees. And then what did we do? We got a contradiction. Okay, we reason logically until you come up with a contradiction. And so at the very end, our third step says what we assumed about the right triangle being obtuse is false. Therefore, you cannot have an obtuse angle. Let's go back and look at these again. Make the assumption that this conclusion is false. Okay, so we said that a triangle can have an obtuse angle. We reason logically to come up to a contradiction. That's where we did the 90 plus 100 equals 190. And that contradicts the fact. What's the fact? The fact was that a triangle cannot, or the fact is that the sum of the angles of a triangle is 180 degrees. All right. Now, point out, since the assumption leads to a contradiction in the original conclusion, what you were asked to prove must be true. All right. And that's exactly what we did right there. So those are our steps. So that is basically a, it's not basically, it is. It's an indirect proof. That's the kind of stuff we're doing. Let's try one more, okay? And just to kind of get us in the swing of things, and then we'll be done. Okay, this kind of looks like a regular proof, doesn't it? But again, what are you trying to prove? You're trying to prove that something is not equal to something else. So that gives you a big indication that we're going to go indirect proof here. So let's do this. Let's mark some stuff up here. MO and ON are equal to each other. So we mark that equal to that. But here's something that's a little different. They tell you two segments are not equal to each other. MP, this one right here, and NP, this one right here. We're trying to prove that they are not equal to each other, or not we're trying to prove, it's given that they're not equal to each other. So how do we show that? I don't know, let's put like 2 here and 3 here, right? So that shows that they are not equal to each other. This has 3 tick marks, this has 2 tick marks. So they're not the same, so they're not equal to each other. And we're trying to prove that angle MOP, this angle up here, is not equal. That's a little different. We've never proved something is not equal to NOP, this one right here. I want to prove that this angle is not equal to this angle right here. So we're going to do it indirectly. So what do we start off doing? We always start off with an assumption. Okay, so we assume the opposite of what we're trying to prove. We're trying to prove that they're not equal. So what are we going to assume? We're going to assume that they are equal or congruent, whatever word you want to use there. So I assume that they are equal. Now, what we're going to do is work logically and try to come up with some kind of contradiction. So I'm assuming that they are equal to each other. So let's mark them. If I assume that they are equal to each other, let's mark them equal to each other. So this angle and this angle, we're going to mark equal to each other. All right. Well, let's see. What can we do now? I've got a side, right? I got 2 triangles. So the first thing I'm thinking about is using congruent triangles maybe. So watch this. This side is equal to this side. This angle is equal to this side. What else do we have? How about OP? And I got all these marks here. Let's go 4. Okay, so I've got, look at what I have. I've got side, angle, side. And I've got side, angle, side. So if I assume these 2 are equal to each other, I can also say, I can say I know, or we can say we know, or I know, whatever. We know that OP equals OP because of reflexive property, all right, or congruent to each other. So what can we say? We can say that triangle MOP is congruent to this triangle NOP. And what's my reason? It would be side, angle, side. All right, so look, by knowing that information right there, assuming that these 2 angles are equal to each other, okay, that's what we have to do. If we assume they're equal to each other, I can say that these 2 triangles are congruent because of side, angle, side. So if they're congruent to each other, that means the corresponding parts have to be equal. So that means that if these triangles are congruent, then MP, line segment MP, must be equal to line segment NP, or congruent to NP. And why? Because of corresponding parts of congruent triangles are congruent. CPCTC. All right, notice what we've done. I assumed that these were equal, and then I reasoned logically. So I said, I already knew that these two sides were equal because it was given. I saw that this is reflexive. If you want to put a reason right there, you could put reflexive. Put it in parentheses if you wanted to. So it's reflexive, so my triangles are congruent by side, angle, side. If the triangles are congruent, that means that the corresponding sides are going to be equal to each other. So that means that MP must equal NP. But wait a minute. What were we told at the beginning? We were told that MP was not equal to NP. So that's a contradiction. They can't both be equal and not equal at the same time. So this is a contradiction. So I'm just going to write, this contradicts this statement right here, that MP equals NP. This contradicts what? It contradicts the given. It contradicts the given that says MP is congruent or equal to NP. There's our contradiction. Right here, we reason logically. We came up with, is not equal to. Woo. Okay, so MP is congruent to NP, but this contradicts the given that says they're not. So we just came up with a contradiction. That's what we were trying to do. Okay, the whole reason behind doing this is to come up with a contradiction. We did. We came up with a contradiction that says, wait a minute, MP and NP, it says they're equal to each other here, but the given says they're not equal to each other. They can't be both. That's a contradiction. Oops. So it contradicts the given. And then we can say, let me see how they write it. Conclusion. Yeah, we got the information. Okay, we could say they use this word, thus. How many times do you use thus? Thus, the assumption is false. And that's a nice, easy, simple way to write it. The assumption. What assumption? The assumption right here. If you want to write it out, you could. The assumption that says angle MOP is equal or congruent to angle NOP is what? False. Make that real big again, just so I can see where my contradiction is. All right? Even underline it. How about that? So our contradiction is false. Therefore, we always end up with that. Therefore, if this statement is false, then what can we say? We can say that angle MOP is not congruent to angle NOP. And that's what we're trying to prove right there. That's what we were trying to prove. We went through this, and we actually got it right at the end. I know it sounds a little confusing, but after you get used to these, it kind of starts making sense after a while. But at first, I can understand where you'd be a little bit flustered with it and not really understand what's going on. But hopefully through these couple examples and through my little silly story about the umbrella, I hope it makes a little bit more sense. You could always look it up online, but I tell you what, I did a lot of research and I did a lot of looking on YouTube for explanations of this, and there's not too many really good, easy explanations. So I think this is just as good as any of them, or maybe even better than some of them. So good luck with it. Again, we'll take some time in class. We'll go over it and help you understand it a little bit better when you get into class. All right, good luck with this.